The next lesson is very similar to the angles of elevation, and it's angles of depression. An angle of depression is formed by a line of sight in the horizontal plane for an object that is below the horizontal. And generally speaking, if this is the horizontal, you're going to be looking down, and anything below the plane, the horizontal plane, will be an angle of depression. So we are going to name the angle of depression here. So we're going to name it. So the angle of depression, well, here's the horizontal. The angle of depression is this angle here. I would name that angle DCA. What is the measure of the angle of depression? Well, that's a very good question. There's two ways to think about angles of depression. First way is we could simply make a vertical line to the horizontal so that it forms a right angle. Okay, take that back. You could, but that's not where I'm going. What we're going to do is we are going to acknowledge that angle DCB is 90 degrees. And if this is 72 degrees, that implies that this must be the complement of 72, which is 18. That is, this angle here has to be 90. So 90 minus 72 is equal to 18. Because this is simply the angle of depression from the horizontal down. A search and rescue helicopter spots a lost hiker at an angle of depression of 31 degrees. The helicopter is flying 1,100 feet directly above the ground rescue crew. How far is the ground crew from the hiker? So here is the hiker. Here's our helicopter. The angle of depression is 31 degrees. Now, if you're taking a look at this shape here, you may recognize that it is in fact a rectangle. And you can exploit the fact that it's a rectangle. That is, this side is equal to this side. And you know that the helicopter is 1,100 feet above the ground. That implies that also this is 1,100 feet above the ground. So the distance I am outlining in green must be the same. So I'm just going to take a look at this. I could look at it like this. And I would like to find x. So that is the triangle that I'm going to set up. And I know that you're able to do this. So now that I've drawn my picture, I could call this angle theta. So tan theta is equal to opposite over adjacent. Tan theta is equal to opposite over the adjacent. Now I've ran out of room, which is unfortunate. We'll multiply both sides by x. Then divide both sides by tangent of 31 degrees. And what I get is 1830.707. And this would be feet. So there we have it. Now, if you don't mind, I'm going to go back and revisit the question. Hopefully I've satisfied then your curiosity, get it right. But I actually have a hard time thinking of the triangle like that. It's not intuitive for me. It's not how I look at it. I think that I actually might see it a little bit differently than most people, and maybe you see it this way too. So when I'm dealing with an angle, and I know that this angle is 31 degrees. Well, that implies that this angle also has to be 31 degrees. And that is kind of weird, is it not, that I can just instantly make that assumption? Well, these are called, I believe, alternating interior angles. But allow me to explain myself. I know that this helicopter is 1,100 feet high. Maybe, just maybe, I'm going to ask myself, well, if this is 31 degrees, how much is the complement, the blue angle? Well, it's the complement because it adds up to 90 degrees. So this angle right here is actually 59 degrees. And by the way, what is this angle here? I actually don't need this angle down here, but this angle is 31 degrees. I'm just going to cross that out. So instead, I could solve this triangle. And this is 1,100 feet. This is 59 degrees. And there's my triangle. I want to know how far I am. Now let's see where I go here. Well, this is theta. This is theta. With respect to theta, this is opposite and this is adjacent. Well, it's kind of weird because we almost have a different ratio. So the tangent of theta is equal to opposite over the adjacent. So the tangent of 59 degrees, if I'm plugging in my known variables, is equal to x over, the opposite is x, over my adjacent is 1,100. So x is equal to 1,100 times the tangent of 59 degrees. So I know that I'm using a different calculation or a different angle in my calculation, but as long as I set it up correctly, I should end up with the same answer, and lo and behold, I do. So how far is the ground crew away from the hiker? It's 1,830 feet, 1,830 feet, 30